Lesson 1-7, Functions. Our essential question is, how do you determine if a relation is a function? In lesson 1-6, we talked about what a relation is, and we said that a relation was a set of ordered pairs. Now, if that set of ordered pairs is a function, then there's a special relationship between the domain and range that has to be true. So for a relation to be a function, each value in the domain is paired with one value in the range. It's a one-to-one mapping. So to be a function, each domain value corresponds to exactly one value in the range. To test to see if something is a function, we use what's called the vertical line test. The vertical line test is super helpful when you're looking at a graph. When you're not looking at a graph, we'll talk about some different ways that you can use it on the following slides. But for our graphs, we definitely want to use the vertical line test. So I am going to draw some graphs here, and I'm going to show you what the vertical line test looks like. So for my graphs, I will do, let's say I'm going to have one graph that's kind of curvy like this. I think I'll have one that's kind of sideways like this. I'm going to have one that's got a bunch of dots like this. And I think I'll have a regular line over here like that. Okay, so the vertical line test. When you do the vertical line test, what you're doing is you're basically drawing vertical lines through your graphs. And in order to be a function, your graph has to pass the vertical line test, which means that each vertical line can hit your graph only once. So this is a function, yes. This one, however, if I draw vertical lines through it, if even one vertical line hits your graph twice, like this right here, then it is not going to be a function. The next one, when you're working with dots, as long as each dot is on a separate vertical line, it's a function. And then this one over here, each vertical line hits once, so it's a function. So my examples, I only had one that failed the vertical line test. I had 3 that were functions, 1 that was not. Okay, our last new vocab word, so we have function and vertical line test. Our last one is function notation. Function notation means that you're going to start with the letter F, F for function, and your function is in terms of another variable. So the most common function is f of x. So for example, f of x equals 5x minus 2 is a function in terms of x. So the independent variable, the input variable is x. So it's a function in terms of x. All right, let's try out that vertical line test. So I'm going to take my graph and clone it over here. And I'm going to use my line drawing tool to draw some lines to see if it passes the vertical line test. Each of these lines has to hit my graph once. They're not exactly vertical, but we'll accept it. Each one hits once, so yes, that passes the vertical line test. My next graph. If I check my vertical, if I check to see if it passes the vertical line test, each vertical line has to hit once. Not happening on this one. This vertical line hit twice. So did this one. If even one vertical line hits 2 points, it does not pass the vertical line test. two more that are graphs. That didn't work to clone. Okay, here we go. Check the vertical line test. Each one hits one dot. So this one passes the vertical line test. And my last graph, this one might be a little tricky for some of you. If I draw vertical lines through this one, most of them don't touch the graph at all, but look at this one over here. It hits every point on that line, so that one definitely fails because one vertical line goes through every point on that entire graph. So it definitely hits more than once. Okay, now let's talk about tables. Let's talk about tables. What I'm actually going to do for this one is I am going to graph this one just so that you can see where we're coming from here. So we've got -7, -12, -7, -12 would be like about here. So my graph goes to 10. -4, -9 is about here. 2, 3, and 5, 0. Okay, so if I draw vertical lines through these points, this is going to pass. These are all clearly on separate vertical lines. And I want you to notice in the table, we didn't see anything repeat. The domain numbers and the range numbers were all different. Okay, now this next one. What happens if we graph this next one and look at it? So fit my graph over here. 3, 2. It's right here. 1, -2 down here. 2, -4. And then 3, -1. So if I draw vertical lines through these points, you see that this does not pass the vertical line test. Now, if we go back to the table, I want you to notice what caused that to happen. Those 2 points were 3, -1, and then 3, 2. So what they had in common was they had the same number in the domain. So the reason that it fails the vertical line test, the reason that it fails is because the values repeat in the domain. So to give a reason for these, because when you take your test, you're going to have to explain these. So are these functions? The first one I'm going to say yes, because it passes the vertical line test. You can use that as a reason only if you draw the graph. I drew the graph. I used the vertical line test, it passed. So this next one, I could say, no, it fails the vertical line test because I did draw the graph. But instead, I'm going to say, no, the domain repeats. Because if you can remember that, you don't have to draw the graph. So it fails the vertical line test, true, if you want to draw the graph. But now that I recognize what causes it to fail the vertical line test, I'm not going to have to graph in the future. If I go back to these slides, because we should have written a reason, because all of these should have the explanation part. So I'm going to say, yes, it passes the vertical line test. No, it fails the vertical line test. And I always abbreviate the vertical line test, VLT. Same here, so yes, passes the vertical line test. No, fails the vertical line test. Okay, so now we're back to where we were. Next up, mapping. Mapping. Now remember what we just found out, that if the value in the domain repeats, it's going to fail the vertical line test. Well, this one, I happen to know if I write the ordered pairs, -1, 3, then we've got 0, 3, then we've got 1, 3. Well, I'm not quite sure what to expect when the range repeats. So I am going to graph one more. Even though I just said I wasn't going to graph, I'm going to graph one more. Because on this one, we've got -1, 3 up here, 0, 3, 1, 3. Okay, so I just wanted to make sure. Perfect. Passes the vertical line test. So if we have a repeating number like this, 3, in the range, that doesn't matter. It doesn't matter. It's just the domain that cannot repeat. So yes, this is a function because it passes the vertical line test, or I could say there are no repeats in the domain. So no repeats in the domain. That's what I'm looking for when I look at a mapping. This next one, right away if I look at the domain, I see right here, the domain repeats, X repeats. So I know this is not going to pass the vertical line test if I graph it. I'm going to say no, the domain repeats, or X repeats. So it is not a function. Each value in the domain has to correspond to exactly one value in the range. This domain value, -3, doesn't correspond to exactly one value. It corresponds to 2 of them. So it does not represent a function. Okay, next, ordered pairs. Look at the domain and only the domain. So first number in every ordered pair, are they all different? Yes. So this is a function. So no domain numbers repeat. And the last one, -2, 0, -2, 1, no. The -2 repeats in the domain. Okay. Now that we've mastered figuring out if something is a function, we are switching over to some function notation next. Here we go. We have two different functions. F of x equals 3x squared, and g of x equals 4x minus 5. Evaluate f of 5. Okay. F of x equals 3x squared. Evaluate f of 5. Now what I want you to notice is that the x right here was replaced with a 5. So what we are going to do on the other side over here is we are going to replace this x also with a 5. And then we're going to use the order of operations. So the order of operations says that we are going to do parentheses, exponents, multiply, divide, add, subtract. And remember, each of those go left to right. So I'm going to have to do the exponent. So 5 squared is 25. 3 times 25 is 75. So f of 5 equals 75. My next one, g of -2. Well, g of x equals 4x minus 5. So g of -2 would equal 4 times -2 minus 5. So just like on the last one, the x on this one was replaced with -2. So the other x is replaced with -2 as well. Order of operations, 4 times -2 is -8. -8 minus 5 is -13. Next, we have f of -1. So going back to my first function, f of x equals 3x squared. And now we're replacing the x with a negative 1. So replace both x's with negative 1. Negative 1 squared is positive 1. So 3 times 1 is 3. So f of negative 1 equals 3. And last but not least, we have g of h minus 1. So this one looks a little bit trickier. G of x equals 4x minus 5, and I'm replacing it with h minus 1. So where the x is, I need to replace it with h minus 1, like this. So I took the x, and I replaced it with h minus 1. I took the x and replaced it with h minus 1. Notice I put it in parentheses. That's important because you should remember that we need to distribute this 4 over here. So it would be 4 times h, or 4h, minus 4 times 1, which is 4. Then I've also got my minus 5 on the end, so 4h minus 4 minus 5, well, like terms can be put together. Negative 4 combined with negative 5 gives me 4h minus 9 for my final answer. So because there was a variable, the part that was being substituted in on this one, because there was still a variable there, I still have a variable in my answer this time. So this is using function notation to evaluate a function. We'll practice more on that tomorrow. You should be able to write a summary now explaining how you figure out if a relation is a function. Remember to keep in mind that you may be looking at the relation as a set of ordered pairs, a table, a graph, or a mapping. Any of those different ways.